we go edit, we type in our stuff. 1996, 1998, 1999, 2002. Make sure you have all your things in. 2003, 2004, 2007, 2008, 2009, arrow over, 78.04, 79.14, 81.16. And this is talking about the distance that a bike rider rides in an hour for the Guinness Book of World Records. So it is increasing the distance with time because in 1996, I bet you the bikes were. Okay. So I told you that this is a linear regression yesterday, right? Everyone's phones are down, everyone is paying attention, everyone is taking it in. We're doing lots of different things. So we went stat, calc, linear, which was 4, and then you did whatever way you had to, which we went through yesterday, to get into your y equals. Now you should have that in your y equals. Everyone has that in their y equals? We did this yesterday, we're just repeating. All right, then we go to our window. Your window may be different than my window. If you, like, I see 1996, I'm like, I want to be a little lower, so I go to 1980. If you are someone who sees 1996 and you go to 1990, totally fine. We could both be wrong, because they might ask for 1976, and then I have to go lower, right? So what we do need to know is, we set a window, but we might have to adjust it totally based on what they ask us for. So I'm going to go 1980. And then I'm going to go 2020. Could have went higher, doesn't matter. And then this can go up by whatever. I'm going to make it go up by 10s. You can keep it at 1. All the X scale is what the ticks are worth, right? So if you make the scale really small, you just have a solid black line because there's so many ticks, I'm not going to change them. My Y minimum, I'm going to make be 70 kilometers. My Y maximum, I'm going to make be 100. And then I'm going to make these go up by 5. You could leave it at 1. No big deal. It's just that I'll see some ticks. So here I can see ticks because it made it go up by 5. And that's what I wanted it to be okay. Okay, so we see the graph. We agree? We're going to look at the front side of our sheet now. Not the back side. We're looking at the front side. So A says how to enter it in. We've already done that. B says how to adjust the window. We've already done that. We're now just looking at C, D, E, F, and G. So C, determine a Y when you know an X. So in this case, for this question, they could give you an X and ask for a Y. So let's go here. They said, a possible world record distance for the year 2006 to the nearest hundredth of a kilometer. Compare your estimate with the actual world record. So the actual world record in 2006 was this. Okay, so it was actually this. We need to find out in 2006 what the world record would be using our line best fit that we have, correct? So we have to decide, did they give us an X or did they give us a Y? That is what we need to decide. So if they gave me 2006, I go up here and I know I put this into list 1, so it's X. I put this into list 2, so it's Y. So did they give me X or did they give me Y?
X, you said it first.
They gave me X because I said it first. And they gave me X because they gave me the year. And the year is in the X spot, correct? So I know X equals 2006, and I want to know what Y equals. So on my little chart, it says, determine Y when X is known. So press calc. How do I press calc? What do I do to press calc?
Second trace.
Second trace. And then when I know X, I will always press value. Anytime I'm given an X, I can press value, and it will kick out a Y. So now I go 2006, and it kicks out 86.38.
Is that better than like tracing the line?
You don't trace. Do not use trace ever. Because it will not get you accurate answers. You make it like 86.42 and the answer is 38. You get it wrong every single time. Okay, I want you to try to give me the world record in 2024. So it's still X. I'm gonna go second, trace, value, because I know X, and I go 2024, enter. Why is there an error?
I don't
Yeah.
know.
Right. Your graph can only calculate what it can see. And what did I make my X max be?
Oh.
2020.
Not
So
bad.
I specifically picked 2024 so the error screen would come up. Genius, I know. Not my first rodeo with this lesson. Okay. So we go to window. We go to go to. It tells us that. This is, if you said go to, it gives you the error. The error is 2024. It's really not the error. The window is the error. I have 2020, so I need to go like 2025, then it'll fit in there. And then I go second, trace, value, 2025, and I get 102.69 kilometers.
The rest for 2020.
I asked for
Great.
2024.
That's not bad.
So if I get an X, I plug it into the value, get out a Y. Yeah.
That's what I got.
I put in 2000. Put the wrong. I put in 2025. Silly Billy. 101.83. Okay. Instead of giving you Y, what could I give you? Sorry. Instead of giving you X, what could I give you?
Why?
Y. Wow, I really oops that one. So I could give you Y instead. Y is what on this chart?
Distance.
Distance, kilometers. So I need to give you some sort of distance or kilometer and then ask for the year. We agree?
1,096.
Yeah, that's aggressive. I am going to pick one that falls in there. So I'm going to say, what year is there, did they make the record of 80, I'm going to go 92.1. What year is 92.1? Kilometers. So did I give you X or Y?
Why? So how do we do that? Can't use the side.
Just punch in a random X.
There's another part on your sheet in front of your face. So we have Y equals 92.1. So we did C, which was determine Y when X is known. Oh, but there's D, determine X when Y is known. So if I have an X, paying attention, if I have an X, the only place there's too many phones out, and if I see a phone, I need to put it somewhere. Sure. Okay. If I know an X, I go second trace value, put in my X. Where's the only place I can put Y equals in? The Y equals button, correct? So here it says press Y equals. That's where you're going to put it. So you're going to go to Y equals, but you're not going to clear out Y1. Your entire graph's going to clear out Y1. You're going to put it into Y2, which is 92.1. Now press graph. If you can see where they intersect, you can calculate the answer. If you can't see where they intersect, you have to make your window bigger. Yeah.
You can also go to trace distance.
That's what we do. So we need to find out where the two do what?
Cross.
Cross.
Intersect.
Intersect. And where do we go when we want to calculate stuff?
Second.
Second, trace, which is calc, number 5. And then enter, enter, enter. It's at 2012.66. What do I have to say then?
2013.
2013. What if it was 2012.11?
2012.
2013. They wouldn't have repeated it in 2012. You would have to wait until 2013 until they got to that distance.
Question matters.
You have to watch yourself. You have to read into the question.
You're under 8 gamers.
Really broad and sick. Not always ground up, but it's not a true state. There are situations where you always ground up. For example, if I was making you get paint for the room, If I was making you get paid for the room and you figured out that it took 3.4 cans of paint, could you buy 3? No, you'd have to buy 4. So in that instance, you have to round up. So there's case 3 at round up. If you're putting cows into a trailer, okay, and 4.3 cows fit in the trailer, okay, or say, let's say 4.7 cows fit in the trailer. So you just like cut the end of the cow off. No, you're gonna have to back the cow out and be like, I guess we're fitting 4 in. So there's certain instances where you have to round down and certain instances where you have to round up that do not find rounding rules. Okay? And do not cover rounding rules.
What if you put liquor
No. It's still fit 4.7. But thank you for your offering. No, you understand how it sucks, girl.
I feel like it's.
Okay, so it'll be 2013. Wow, thanks, board. Thanks for joining me. Sounds great. Okay, we're moving on to example 2. We're not going to do all the examples. We're going to skip some, but we're doing example 2. What's the very first thing you have to do? Clear your y equals. Go back to the t-shirt question, and I told you yesterday that this was, it was in the form y equals mx plus b. So that's what I need you to do, y equals mx plus b. What form is that? Linear. Clear out your y equals, clear out your list, start again. Get it on your calculator. So, we're going to go stat, calc, linear. Get it into your y equals. Now we're going to change our window. The window, the x is number of shirts. How many number of shirts can I minimum out at? 0. And the highest number of shirts here is 740. I'm going to do 1,000. And then this one, my y minimum cost per shirt would be 0. And the highest it is 520, so I'm going to do $8. I'm going to make it go up by 1. So I have a graph in front of me that's decreasing, which makes sense because as we buy shirts, the more shirts we buy, the cost of shirt goes down. That's how it works when you buy something in bulk. All right. Yeah. So there is actually an amount that would give you that. Is that real in the real world? No. But that's what the linear regression is about. So we're going to go here. Everyone's paying attention? This one says, Matt has misplaced the information from his supplier about price discounts on bulk orders. He would like to get the price of the shirt to be below $1.50. Did I give you X or did I give you Y?
Y.
Because X is here and Y is here, so I gave you Y equals $1.50. And when I know Y, I put it in where?
Oh, it says Y2.
Yeah, I'm going to put Y50 in the round properly. You don't go 149.
Why?
So we put in the actual value. We go to our Y2. And we put in $1.50. Shh. Quiet, please. And we press graph. If we can see where it intersects, we can find out where it intersects. If you can't see the intersection, no matter how hard you press enter, it ain't going to do it for you. So we're going to go second, trace, 5, enter, enter, enter. Now, if I buy 769 shirts, it gets me to $1.50. I need to go below $1.50. So if I buy 769, it's at $1.50. So I actually have to buy how many to get it below? 770. So it doesn't matter what the rounding rules are. I'm going to go up to 770.
What in yours doesn't do that?
Pardon?
Like, how did you get that? Because even when I grab the intersect, it's not giving me some reasons.
Are you putting $1.50, not $1.50 into your Y2? What if I give you an X and I want a Y? What would I have to give you?
Number of shirts.
Number of shirts. So I'm going to say, how much would the cost be per shirt if there are 150 shirts? So if I gave you 150 shirts, am I giving you X or Y? X. So if I know X, how do I find Y? every single time. Second trace. Now you might want to take your Y2 out because it'll find it for that one as well. So second trace value,
How many?
Enter
150. Make sure you take out your other thing. So it'd be $5.50.
2 cents.
Three. Can't have half a cent.
Technically, you could.
$5.53.
I got the right answer, but I kept my Y to it.
Yeah, it's okay as long as it pulls to the right equation.
5 cent.
Because it'll try to find the value of each one of them. Usually does it in one way. We're usually okay. All right. We're going to do example 3, and then we're not doing 4 and 5, so don't start doing all those. Or we're not going to do, yeah. We're going to move on past example 3, then we're going to go to example 7, just so you know. So we're going to example 3 next. So what's the very first step we're going to do? Clear out your Y
Clear them right out.
and your list.
Don't delete them.
Yeah.
Next, do something later.
Okay. So stat, edit, clear list. Remember, this was the question about after 1970 or 1960. It was a world record of men's 100-meter sprint. So we have 0, which would be 1968, which would be 1968, and then 1983. Ooh, yeah, that's fun. 31, 36, 39, 45, 38. Yes, that's fine. Good catch. Okay, and then in our list 2, we have 10, 9.95, 9.93, 9.86, and they're getting faster, right? As the time things improve. Okay, so we go stat, calc, and it said linear on it. Okay, so we have this, guys, looking at that. Sometimes they literally just want, all they want is the equation. Sometimes it's all they want. Sometimes they just want the b of the equation to the nearest 10. So what would the b of the equation be to the nearest 10? 10 decimal 0. You'd have to put the 0 because that would be to the nearest 10, right? Honestly, when they ask something about the equation, you guys will often do way worse than when you have to do way more work. This should be the easy part. How did you get that?
Because I was doing
How did you
research.
get that? How did you get that?
Because I was doing research.
I was putting
I see what you were doing, but put it down. You're researching, failure. I got it.
I squared in an R.
Yeah, I just have it. Mine here doesn't have the catalog on, remember? Your guys' has the R squared and the R and stuff because mine has been reset every single time your board brings it back up. So it doesn't have the catalog on anymore. So I have to turn the catalog back up. But my equation, if I went to write it out, I would write it as Y equals negative 0.00665171129 x plus 10.032869777. You see how you would write it out? It literally just gives you the format, and you put those into the A and the B. Do you see that? Okay. If I asked you for the y-intercept, what would the y-intercept be? 10.03, right? Because my constant is over my y-intercept. We talked about equations in this way. So the actual question itself says, describe the characteristics of the trend in the data. So if I go to my window and I change my window, this would be, remember I told you your x min should be negative, because if I ask you for anything under 1960, you would need negatives. So I'm going to go negative 20, so that would get me to 1940. And then I'm going to go 100, so that would take me to 2060, and hopefully that's enough. Makes 12 by 5. Then my y min would be, they could run it in no time, which means they didn't even try. and then 10 is as high as it's going or it's going lower. Remember, if we go lower, it would be a higher number. So I'm going to do, instead of 10, I'm going to do 60. I'm just randomly picking. So here's my graph. So what could I say? What is the trend that's happening? It is doing what? Yeah, it's decreasing. It would be a decreasing trend, right? So that would be your answer, just decreasing. Decreasing over time. Then it says, determine the equation of the linear regression function that models data. What do we have here? So what does the slope and the y-intercept represent? Y-intercept represents time 0, correct? Which would be 1960. And what does the y-intercept or the slope represent? How much is going down per year? What speed is going down per year? So they want the world record in 2007. In 2007, did I give you X or Y? X. Now, if you put 2007 in, it's going to cause problems. Last time, when we put in 2020 or 2024, it represented the correct thing, right? But I want 2007. If I put in 2007, that's 2007 years after 1960. Is that 2007? No. How many years after 1960 is 2007? 47. So I'm actually looking for when X equals 47, not 2007. You have to look at your table and reason. So I'm going to go, I have an X, I'm going to go second, trace, value, 47. And I get 9.72 seconds. Then it said here, a soccer pal from Jamaica accomplished world record time on September 9th, 2007. Research the time between the difference between the actual time and your estimate, which is what you were doing, I know. But, did anyone look it up?
Yeah, it's
7.74? 9.74? I was like 7.7. So, are regressions foolproof? Are regressions always going to give you the perfect answer? No, because a lot of the time, unless your R-squared value is 1, almost all the data fits, but it doesn't all fit, right? So it could be a little off. This is actually quite close. Okay, I told you the next one we're going to go to is example 7. They're up to y equals, yeah. So this is example 7.
Oh,
That is not a 7. That's a 3. Okay, what did I talk to you about these? When they're like this?
it's 1, 1.
Yeah. So this is list 1, and this is a carry-on of list 1. This is list 2, and this is a carry-on of list 2. So you're going to go 0, 1, 2, 3, 4, 14, 17, 20, and then these, and then these. This is list 2. Now, what I want you to do is do a cube. Whatever, board. You do you. I want a cubic regression. So which number are we picking?
6.
6. And then I want you to estimate the average price in 1984 and 85. And then I want to know what year would it be this price. Okay? So that's what I want you to do. I want you to get a cubic regression. I want you to get it to show up. I want the price in 1984 and 85. And I want to know what year it's going to be 56.0. Try that. So I got my cubic regression. I'm going to go to my window and I'm going to make it fit my data. Yeah, walk off, carry it over here. Yep. Okay. So my lowest number of years is 0, but that's after 1979. So I can go negative 10 if I want. That would give me 1969. And then my X max is out of 29 years since then, but I could do 60 years since then or 100. It doesn't matter. My Y minimum is price of gas. Well, the lowest it could be is 0. The highest it is on here is 115.29. So I could go 150. We know we can get there. It's past that. So we press graph. And we have a cubic line, right? Here it wants in 1984. 1984 is how many, so it's years, this is X, this is Y. So it wants the price. So it gave us X. 1984 is how many years after 79? 5. And 1985 is 6. So I'm asking for 5 and for 6. When I know X, I go second, trace, value, 5, enter. Remember, if I get an error, it means my window is not actually the size it needs to be in order to do the values. So this one would be 48.45 cents per liter. And then I do second trace value 6, which is 47.15 cents per liter. This is in 84, and this is in 1985. Okay, it was quite a while ago because I was 1 and 2. Okay, if you were thought of, that's fine. Yeah.
I got 34.2.
So which one?
Yeah.
48.85?
44.20. 44.20.
No, well, it's just a guesstimate. You've got 44. All of you.
Sounds like you're wrong in the price with your guys.
You got 47.15?
Yeah.
Maybe. Oh, it is 44. I'm pretty sure it was 44, and I just wrote 48. Let's check. Second trace. Well, that's so much better because then I don't go back to my chart. I'll take it. I think it was 44, and I wrote 48. I think I'm just an idiot, and it's fine. Ah, see, I said 44 and wrote 48.
We all have those names, that's why we should watch further.
No. Okay, and then we need, what's the average price, and it's 56 liters, so that's our Y2. It's our Y. So we go 56. Second trace 5, enter, enter, enter. And it's 16.46 for 17 years. And it wants the year. So what is that? No, that is 17.
Oh,
So we have 1979 plus 17.
1996.
Why am I putting 76? Kate might be onto something with her movie. 1979 plus 17, 1996. All right, you have some homework. One second.
Oh, man.
So it is going to be page 314 in the textbook, numbers 3 to 6. You have to read what regression it says. Also, paying attention. Your X is your independent, your Y is your dependent. They have some of these flip-flopped. It's easy to tell which is the independent one because it's the one without all the crazy decimals. Your Y should be the one with the crazy decimals. That's the one that's changing. So for example, number 3 is time in the X, height in the Y. Time is 1, 2, 3, 4, 5. So yeah, it's in the right spot. Number 4, it has volume in the X and time in the volume of this one, time in this 2. That's not right because the time is 0, 1, 2, 3, 4. So time is actually X and volume is Y. So you have to put these in list 1, list 2. They're on the opposite spots, right? Then for number 5, same thing. Temperature 0, 5, 10, 15, 20, 25, 30. It's a nice one. That's going to go in list 1. Volume is going to go in list 2. And then for 6, time in seconds is 0.5, 1, 1.5, 2.5, 3.5. Height is 0.59, 1.22, 1.39. So height should be in list 2, and time should be in list 1. So Actually, 3 is the only one that's in the right order. Then these 4, 5, and 6, this one was 2 split. You know what I'm saying?
Yes.
Okay, I will be checking 3, 4, and 5 tomorrow, and I'm gonna post them.